Good morning, class. Today we are going to learn about linear systems of equations and augmented matrices. Here we see 3x minus 2y is equal to negative 4. There is no z in row 1. In row 2, we have 1x plus 5z is equal to negative 3, and no y in row 2. And we have negative 4x minus 1y plus 3z is equal to 0 in row 3. Now when we augment this linear system of equations, we have to put 0 as a placeholder when a certain letter doesn't exist in a particular row. So we will say 3x minus 2y plus 0z is equal to negative 4. 1x plus 0y plus 5z is equal to negative 3. Negative 4x minus 1y plus 3z is equal to 0. Now, to augment this, it will be in row 1, 3, negative 2, 0, and negative 4. Row 2, 1, 0, negative 5, 5, and then negative 3, and then negative 4, negative 1, 3, and 0. Now the middle row will have to be used twice. So the first set of linear systems of equations, we will have 3x minus 2y plus 0z is equal to negative 4, and 1x plus 0y plus 5z is equal to negative 3. And in the second set of linear systems of equations, we will have 1x plus 0y plus 5z is equal to negative 3, and negative 4x minus 1y plus 3z is equal to 0. Here I am going to show you how these equations break down when we eliminate x. So in the first set of linear systems of equations, we want to multiply row 2 by negative 3, and we will obtain negative 3x plus 0y minus 15z is equal to 9. And row 1 will stay the same at 3x minus 2y plus 0z is equal to negative 4. So when we simplify, we will obtain negative 2y minus 15z is equal to 5. And then in the second set of linear system of equations, we will have 1x plus 0y plus 5z is equal to negative 3, and negative 4x minus 1y plus 3z is equal to 0. So we want to multiply row 1 by 4 to eliminate x, and we will obtain 4x plus 0y plus 20z is equal to negative 12. And then row 2 stays the same at negative 4x minus 1y plus 3z is equal to 0. When we simplify, we will obtain negative 1y plus 23z is equal to negative 12. So now we have both of our new linear systems of equations, and we will simplify to find y and z. So when we put that together, we have negative 2y minus 15z is equal to 5, and negative 1y plus 23z is equal to negative 12. And we want to multiply row 2 by negative 2 to eliminate the y. So row 2 will change to 2y minus 46z is equal to 24, and row 1 will stay the same at negative 2y minus 15z is equal to 5. And then when we simplify, we will obtain negative 61z is equal to 29, and then we divide both sides by negative 61, and z is equal to 29 divided by negative 61. Then we substitute this in for z in the equation that says negative 1y plus 23z is equal to negative 12. So negative 1y plus 23 times 29 over negative 61 is equal to negative 12. So negative 1y plus a negative 667 over 61 is equal to negative 12. Then we add 667 divided by 61 to both sides, and we will obtain negative 1y is equal to negative 65 divided by 61, and divide both sides. And we need to divide both sides by negative 1 to obtain y is equal to 65 over 61. Now we will continue on the next page. Three x minus 130 over 61, and we get this from the previous section when we substitute z and y results into the equation that states in some of the equations you don't need to plug in both results. We'll just plug in to the first equation and we will solve for x. So we will plug in the value for y, so it will be 3x minus 2 times 65 over 61 is equal to negative 4. So 3x minus 130 divided by 61 is equal to negative 4. So we add 130 divided by 61 to both sides. And then 3x is equal to negative 114 divided by 61. Then divide both sides by 3, and x is equal to negative 38 divided by 61. So now we have all of our solutions for x, y, and z, and we can list them as a coordinate. So the x is represented by negative 38 divided by 61, comma, 65 divided by 61, and which is the y, and z is 29 divided by negative 61. So if you need math tutoring, please text 559-744-3169 for services. Please donate on the Cash App with the $sign up front, MLBFan. Again, my Cash App is with the $sign up front, MLBFan. Thank you so much, and let's make math fun to learn.